we're going to get into a discussion of formal charge, a very important concept, especially when it comes to drawing the Lewis structures of polyatomic ions and molecules with multiple bonding. All right. So, what is a formal charge? Let's define that here. And as you can see here, it is a difference between the number of valence electrons in a free atom and the number of electrons assigned to that atom when bonded to other atoms in a Lewis structure. All right. Now, there's a formula. In fact, there are a couple of formulas that you can use to calculate the formal charge of an atom. The one that I prefer to use is the one I'm about to show you here. Let me open this up. Okay, so this is the formula here for the formal charge, calculating the formal charge of any atom. All right. So the formal charge of the atom is equal to the group number minus half the number of bonding electrons minus the number of non-bonding electrons for that particular atom. All right. Now, let me just say that whenever you're calculating, or I should say, whenever you're determining the Lewis structure for any molecule or polyatomic ion, you need to calculate the formal charges of the atoms. All right. So that you can get the correct final answer as far as the structure is concerned. Now, I did not do that for the previous examples because I already knew that the formal charges of the atoms in the examples that we looked at would be 0. So what I'm going to do is show you how to apply this formula to one of the examples that we worked out. So I'm going to use the nitrogen trifluoride example that we looked at. And if you recall, this would be the Lewis structure of that molecule. That's what it looks like. All right. So well, I'm going to show you how to calculate, firstly, the formal charge of the nitrogen atom, right? So according to the formula, that's the group number, which for nitrogen is 5, minus half the number of bonding electrons, which for the nitrogen it's 2, 4, 6, so that's half of 6, minus the number of non-bonding electrons, which for the nitrogen is 2, right? And if you work this out, you'll see that the nitrogen atom has a 0 formal charge. And then we do the same thing for the fluorines. That will be equal to the group number. Now, this calculation I'm about to show you is for each fluorine atom, for this one, and for this one, right? So basically, the calculation that I'm going to show you here focuses on one, but it's the same answer that you get for the others. And the reason why that is so is because each of these electrons will have the same, or I should say each of these atoms will have the same arrangement of electrons. So the group number for fluorine is 7 minus half the number of bonding electrons. So if you focus on this one here, there's 2 bonding electrons here, so half of 2 minus the number of non-bonding electrons, which would be 2, 4, 6, and that would be equal to 0, right? So basically, all the atoms here would have a formal charge of 0, which means that the molecule itself will be neutral, have no charge, all right? So that's basically how you apply that formula of formal charge to calculating the formal charge of each atom present in a molecule or ion, all right? Okay, so some things here I want to say about the formal charge when it comes to determining the Lewis structure. The formal charge is a hypothetical quantity, and therefore is just a useful tool. It is not a real thing in a sense that there's no such thing as, in most of these structures anyway, there's no such thing as a charge that exists on an atom in most of these cases, right? But it's a useful tool for determining the Lewis structure. In some cases, like in the case of polyatomic ions, there will be a net charge, all right? Okay, the other thing you need to know is that usually most Lewis structures is one with no formal charges. Now, I would say that that is true for most Lewis structures that are molecular. For ionic, or ions I should say, there will be a formal charge that would exist on a particular atom. And it says when formal charges are required, they should be as small as possible. And we're going to see how we can achieve that in some examples that we're going to look at. And when it comes to negative formal charges, they would appear on most electronegative atoms, all right? And finally here, adjacent atoms in the same structure should not carry the formal charge of the same sign. So you can't have 2 atoms bonded to each other and they carry the same plus or the same minus charges, all right? And just to show you an example of 2 plausible structures and which one is more likely, based on the formal charges. If you look at this structure here for carbon disulfide, you'll see that when you calculate the formal charges, all the atoms here will have a formal charge of 0. However, in the case of this arrangement where you have the carbon bonded to the sulfur here, and this sulfur is bonded to another sulfur, what you're going to see here is that this carbon here will have a -2 charge, and the sulfur in the middle will have a +2 charge, right? So basically, according to the rules that I showed you earlier, this would be the most likely structure because there are no charges here. In this case here, because you have a minus and +2 charge here, then basically this would be less likely to be the true structure of carbon disulfide. Okay, so we're going to look at these examples in the next video, all right? And I'm going to show you how formal charges can be used to determine the structures of these molecules. All right, until next time.